All right, guys, in this video, let's talk about some even and odd functions. Here's the textbook definition of function y equals f of x is an even function of x if f of negative x equals, that should have f of x in there. Don't know what happened to that. And it's an odd function if f of negative x equals negative f of x. In other words, it's an even function if you plug the opposite value in and you get the same value out. It's an odd function if for any x you plug the opposite value in and you get the opposite value out. I'll go through an example in a minute here to show you how that's done. Another thing with even and odd functions is if a function is even, it's symmetric about the y-axis. So we have a standard parabola here, and notice it's a mirror image of itself over the y-axis. And that is because if you take any positive x value in and you plug in its opposite x value, you would get the same y value. A function that's odd is going to be symmetric about the origin. What a classic example is the cubic function. And here what happens is that's 180-degree rotational symmetry. If you take a positive x value in, whatever the y value is, figure that out. And then if you plug the opposite x value in, you're going to get the opposite y value out. So the graph is not a mirror image of itself, but if you rotate it 180 degrees, it's going to land on itself for every x value. All right, so let's do a couple examples about how to prove algebraically whether a function is even, odd, or neither. All right, so let's start with f of x equals x to the fourth. If you plug in the opposite of x, that's going to be the opposite of x to the fourth power, or negative x. And negative x to the fourth power, you're going to multiply 4 negative x's together. Negative times negative times negative times negative is going to simplify to just x to the fourth. Well, that's equal to the original function. That means that this function is even. That means that no matter what number I plug in, if I plug in its opposite, I'll still get the same y value back out. However, if I have f of x equals x to the fourth plus x, and I type in, enter f of negative x, you would have negative x to the fourth plus negative x. This is going to simplify to x to the fourth minus x. Notice that is not the same as the original function, and it's also not the opposite of the original function. If it were, it would be negative x to the fourth minus x. So this is neither even or odd. All right. What if I had f of x equals x cubed? If you plug in f of negative x, this would be negative x cubed, which means multiply 3 factors of negative x together. That's a negative times a negative times a negative, which equals a negative. So it's negative x cubed, which ends up being the opposite of what f of x started with. So this is an odd function. And we looked at one like this in the example. Okay. Let me back up a second. And then if you had f of x equals x cubed plus 1, f of negative x is going to be negative x cubed plus 1, which we know negative x quantity cubed is negative x cubed, and then you have plus 1. Now that is neither the opposite nor the same as the original function, because the plus 1 didn't change sign. So this is neither. Okay, so what you do not want to do to prove a function is even or odd is to plug in a number in its opposite, because there could be a situation where a function is neither odd nor even, but a single number that you plug in would give you like the opposite y value or the same y value. But that doesn't mean the entire function is even or the entire function is odd. Might have just been for that one point there. Okay, so hope that was helpful to you in identifying even and odd functions. Take care.